Hello. As I mentioned in the previous video, in terms of finding the domain of a function, right, we're always going to start with the reals unless stated otherwise, and we're going to remove any inputs that we cannot plug in into the expression given for the function. Okay? And as I mentioned, there's really only two things that we have to worry about. Only two things that might force us to remove inputs from the set of real numbers. We already saw one of those things. Right? We already saw that the square root can force us to remove inputs from the set of real numbers, so it makes our domain smaller. So in general, if you have the square root of an expression involving x, and that's what g of x means here, so let me make a note of that. G of x and f of x in this case denote any expressions involving x. So any expressions involving x. Let me make that x a little bit more clear. So if you have the square root of some expression involving x, since we know that we can't take the square root of a negative number, then whatever is inside the square root has to be greater than or equal to 0. So just a quick example. If you have, let me do it here. If you have an expression like, and we'll do this later in an example, but if we have something like the square root of 3x plus 1, and that's your function, let's say this equals y. We have something like this, right? Well, since you have the 3x plus 1 inside the square root, this implies that you can only work with x values such that 3x plus 1 is greater than or equal to 0. So this is restricting your domain. Why? Because it's saying not all x values work. Only the x values such that 3x plus 1 is greater than or equal to 0. The second thing that we're going to be mostly focusing on, so this was the first one. The second one is anytime you have ratios of functions. So if you ever have an expression of x divided by an expression of x, since we cannot divide by 0, right, anything that you're dividing by, you have to make sure that that is not equal to 0. So for example, if you have a function given by, let me use a different color. If you have a function given by, y equals 1 over x. Since we're dividing by the expression of x, just being x, and we cannot divide by 0, then this forces us to have x not be equal to 0. Because if x were equal to 0, we would be dividing by 0. Right? So that's the idea. And other than that, this is basically the only two things that might restrict your domain. Things that might make your domain not be equal to the input set. Now, I do have a third thing written here. We don't have to worry about this now. We'll cover it later in future videos. But basically, we're also going to cover logarithmic functions. Those also have domain restrictions, kind of like the square root function. And we're also going to be talking about trigonometric functions. So these are going to be different than algebraic functions, but we'll talk about them specifically a little bit later in the course. So for now, only worry about square roots and ratios of functions. So let's see an example. So example 1, find the domain of the following functions. F of x equals the square root of 3x plus 1, and y equals 2x divided by x squared plus 2x plus 1. So let's do each one separately and see what we get. So 1, we're given that f of x equals the square root of 3x plus 1. So we already wrote this before, but let me write it again. As we saw in the previous slide, anytime you have an expression of x inside the square root, you have to make sure that whatever's inside is greater than or equal to 0. Right? So this means that, or this implies, remember this symbol means implies. Oops, I did that wrong. Right, so remember this symbol means implies. Right. So the fact that we have the square root of 3x plus 1, that implies that we need 3x plus 1 to be greater than or equal to 0. Okay. Now, we want to write this as an expression explicit for x. Right? So here this is telling us, okay, 3x plus 1 has to be greater than or equal to 0. But that's not telling you explicitly what x values satisfy that. Right? So how do you solve for x in an inequality like this? And anytime you have an expression with an inequality, so this is an inequality symbol, and the inequality symbols vary. They could be greater than or equal to, less than or equal to, or just greater and less. Right? Anytime you have something like that, that's called an inequality, and you solve inequalities the same way you would solve an equation. Right? Just get x by itself on one side of the inequality. The only thing that you have to be careful of when we're working with inequalities is that if you ever multiply or divide by a negative number, you have to flip the inequality. Right? Other than that, it's the same thing. And we'll see an example of that later. But for now, if I want to solve for x here, and solving for x means that you have to, again, that you want to have x by itself on one side of the equation. Right? So just as a refresher of how to solve algebraic expressions like this, inequalities, sorry. So I'm going to subtract 1 from both sides. So I'm going to get 3x is greater than or equal to -1. Right? 0 minus 1 is -1. Then I'm going to divide 3 on both sides. So I get that x is greater than or equal to -1/3. And that's the only other thing you have to remember with inequalities and equalities. Anything you do to one side of the inequality or equality, you have to do to the other side. Okay, so this is telling us that the only x values that work are those for which x is greater than or equal to -1/3. Okay, so then what is the domain of this function? This is the set of all x, and in this case, since again, I don't say anything about the input and output sets, we can assume that they're the real numbers. I'm just going to write the set of all x because we know that x is a real number. Okay. And then what do we need? Well, we need x to be greater than or equal to -1/3. In other words, we're taking the real numbers and removing anything that is less than 1/3. And that's the idea. Okay, so very simple concept. You do have to be careful with inequalities and stuff like that. Now let's work with the second one. So the second one is the function given by y equals 2x divided by x squared plus 2x plus 1. Now, notice here that I didn't write f of x. I wrote y. Right? However, if you remember from a couple of videos ago, we usually denote the output with the y variable as well. Right? So I will be interchanging between the variable f of x and the variable y, but they both mean the same thing. And so let me write that here. Remember that y is just another name for f of x, which is just another name for the output of a function given an input x. So in this function, now we're dividing by an expression of x, right? We're dividing by x squared plus 2x plus 1. Given the previous slide, we have to be careful anytime we're dividing by an expression because whatever that expression is can't be equal to 0, because if it were, we'd be dividing by 0. Okay? So that means that for us in here, we need to find all values of x for which x squared plus 2x plus 1 equals 0. Why do we want to find them? Because once we know what they are, we can remove them from the domain. Right? So we can remove that from the input set, and everything that's left over is the domain. Okay? So how do we find the x values for which the expression x squared plus 2x plus 1 equals 0? Now, this is something that we call a polynomial of degree 2. You don't have to worry about it right now. We'll cover this in more detail once we get further into the chapter. However, anytime you're given an expression like this, and this I will write down, or anytime you want to solve an equation, and remember, solve just means find the values of x for which this equation is true. So solve an equation of the form ax squared plus bx plus c equals 0, right? Where a, b, and c are real numbers. Right? What x values make this equation true? Well, you can find them using the quadratic formula. What's the quadratic formula? So I'm going to state it for you here. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So anytime you're trying to find the values of x for which an expression like this, which again is called a quadratic polynomial or a polynomial of degree 2, anytime you're trying to find the values for which this polynomial of degree 2 is equal to 0, the foolproof way of doing it is using the quadratic formula. This always gives you the correct answers. Another way of doing it is by factoring. I will show you how to do that a little bit later. So let's use the quadratic formula and plug just everything in. So for us, let's see what we have. Given our expression, we have that, okay, what's in front of the x squared? There's a 1 in there. Remember, 1 times x squared is just itself, so we usually don't write it. But that means that for us, a equals 1, right? A equals 1. B is whatever's multiplying the x, so b equals 2. And then c is a constant that's by itself, so c equals 1. Now we plug all of that into the quadratic formula. So we get, let me give this a name here. This is a quadratic formula. So we plug this in and we get x equals negative b, so negative 2 plus or minus square root of 2 squared minus 4 times a is 1, times c, which is 1, all over 2 times a, which is 1. Simplify this. So simplify the inside of the square root. We have 2 squared, which is 4, minus 4 times 1 times 1. That's 4. So we have 4 minus 4. That's the square root of 0, all divided by 2 times 1, which is 2. And if you remember from previous videos, the square root of 0 is always equal to 0. So we get negative 2 divided by 2, and that's equal to negative 1. So what x values make x squared plus 2x plus 1 equal to 0? Well, precisely x equals negative 1. So it applies x equals negative 1 makes x squared plus 2x plus 1 equal to 0. Since we can't divide by 0, right, we know that we have to remove this from the input set, right? So the domain is not going to include x equals negative 1. Other than that, everything else works, right? There's no square root, so we don't have to worry about that. Right? So we're basically done. So what's the domain of this function? And notice that I write the domain of y because I'm using the variable y. And this is something that you have to be careful for when you're doing written submissions. Make sure that the variables that you're using are the same variables that you use throughout your work. Right? So don't switch variables, like don't switch x with t or anything like that in the middle of the work. But given this, what's the domain? So all x element of the reals, and again, you can just write the set of all x such that you don't have to write element of the reals because again, it's given that because I didn't specify differently, it's given already by assumption that x is a real number, right? So any real number such that, well, the only restriction that we have is that x cannot be equal to negative 1. Everything else works. So that is the domain of the function. And that's basically how these problems go, right? If you see a square root, make sure that whatever's inside is greater than or equal to 0. If you're dividing by an expression of x, find for which values of x that expression is equal to 0, and then remove them.